So as we all know, there's a rapidly increasing interest in scalable machine learning, and that's led to a corresponding increase in the interest of integrating R with HPC systems. And so I'm excited to hear about some of the recent developments here today. So first I'll introduce Gergely. Come on.
Yeah, thank you very much. So I'm Gergely Doruzzi, and as you can see, I try to put as many buzzwords and acronyms in this very short title and subtitle as possible. But actually, this is pretty simple. I try to work on a tool which provides an easy way in R to do stream processing. A few words about myself. I like coding. The resolution isn't the best. I mean, 1/3 of the slides is missing, but never mind. So a few projects I worked on in the past. I think the common characteristic is that all of these has an uppercase R in the title. Like I'm running, one of the organizers of the Hungarian R user group with more than 1,000 members. That's pretty cool. Was fortunate to organize the first Saturday conference last year with 200 attendees, and I've been working on a startup heavily relying on R to do online reporting. And 2 years ago, I joined a company called Car.com, which is a prepaid debit card company. And at this company, I worked on the tools that I'm presenting today. Although since then, I joined to a company which you cannot see on the screen because it's somewhere below, but it's called System One, formerly OpenMail. So most important thing about myself, I'm not a Java person. Probably that's because my background is in social sciences, so never really had to use Java, but things have to change. So like 2 years ago, I made this screenshot, and my task was to refactor and fix an ETL job at a company. And after spending a couple minutes, I realized that this is Java. It's like 100 lines of code, and it does one simple thing, transforming a date to another date format. And the transformation is very easy, like getting rid of the minutes and seconds, so just truncating a date and replacing the slash with a dash. So we could actually do that with a regular expression, no need for 100 lines of Java code. So I think that's pretty trivial why we should use R for stream processing, because it's very, very easy to develop R scripts. And why Amazon Web Services? At my previous startup, again, you cannot really see the tech background, but there were many, many different open source technologies used. We used 2 NoSQL databases, CouchDB for reports, MongoDB for user data. We used a network storage for Markdown and the images. We were syncing those between. We used a load balancer for an R-based API. We spent like half year implementing it so that it's secure. We used AppArmor. We also created an R pre-interpreter so that blacklisted function cannot be run. Anyway, we spent a lot of time building an infrastructure, and for a US-based startup, it's not the best way to do. They would rather just pay for the service and use it from day one. And nowadays, I appreciate this approach. So if you have time, it's very good to use open source for everything because you can learn a lot. But if you don't have time, sometimes it makes more sense just to pay a few bucks for those services, especially when it comes to infrastructure. I'm not sure if everyone is excited about maintaining an infrastructure, so it's better just to pay Amazon a few bucks. So a quick introduction into Kinesis, which is the stream processing engine of Amazon. Any of you have used Kinesis before? Just raise your hands. Okay, that's very good. Any other stream processing engine? Okay, thank you. So a quick overview on this. Kinesis is this box here where you can push data, and Kinesis will store that data for 24 hours, and you can read that data with any number of consumers for those 24 hours. So it's like a temporary storage of your records. If we check this in more details, this is not a unified stream, but you have shards in it, and these shards are identified by the partition key. So when you push a record to the stream, you set a partition key for that, and based on the partition key, Kinesis will decide which shard will store that data for those 24 hours. So it's a very, very easy way to handle concurrency problems. So you could use like a username or host name, IP address, something like that to identify your record, and you can make sure that the same user's data will be processed by the same consumer because there's a one-to-one mapping between shards and consumers. So technically what we are doing here, we are starting an R session for every single shard, and every incoming record will be processed. And if you use username as the partition key, every single record for a user will be processed by the same R session. I was told that I really have to mention deep learning just because you cannot give a data scientist-ish talk without mentioning deep learning. This is nothing to do with the machine learning method, but a couple months ago, somehow Amazon's S3 service went down for a couple hours. And why that's interesting for stream processing, because Amazon's Firehose service, which is based on Kinesis, is a hosted managed service so that you push something to a stream and they will write that to Redshift, which is Amazon's Postgres-like database, so that you can power a real-time dashboard very easily. So you are just writing your data to a stream, and it will be in your database within a second. So that's very convenient. But as it turned out, if S3 is down, then your data will be delayed. So I'm just proposing something here. This is rather a pun than a real thing, but just like in R with S4, we have multiple dispatch. You can think about stream processing the same way. So you push your data to a stream, you can have multiple consumers reading and processing the very same record, and you can do different things. Like one consumer can just write his data to your database, another one can compute some new metrics for a dashboard, and the third one can do like real-time risk scoring for your clients. So let's see how to do that with R, how we can interact with Kinesis. There are a number of different ways. Of course, you can use the Row API, you can use some SDKs. There are some client libraries for Java, Ruby, and few other languages. Unfortunately, there's no one for R, so I decided to change that. Here you can see some example code, how to read data from Kinesis if you're using the Java SDK. I'm just using the RJava library here, loading the jar files of the Java SDK, then creating a client to interact with Kinesis. Then I have to create an iterator so that I can get the most recent or first record from a stream, and then I can do the actual record request. And after that, I get back a big Java object. And if I transform that to R, well, you cannot see that here, but it would be basically 6 letters saying foobar, and you wrote like 20 lines to get that simple string, so that's not too convenient. Similar thing, merging and splitting shards is pretty painful because you have to keep track of all this metadata, and we obviously don't want to do that. So instead, I found an approach. Amazon provides a Java daemon, which can provide this feature for you. So this is a Java daemon running in the background, taking care of scaling your application. So the Java daemon is starting the R sessions for your shards. It can take care of checkpointing using DynamoDB. So if your R application crashes or somehow something goes wrong, then this multi-language daemon is called, will just start a new R session and will continue where the previous R session left. So it's very convenient. The only thing you have to take care of, the Java daemon is communicating with R via standard in and standard out. You have to implement 4 methods, 4 very simple methods, like the init phase, which is just starting the application, shutdown, same thing, like cleaning up the workspace, checkpointing that you cannot see here, and the process records where the real processing happens. So I created an MVP for this. This was my first approach to interact with this Java daemon. So in theory, you could just run an R script like this one, which is just an infinite loop. And first we read from standard in, parse the JSON message, and if it says these are process records, request, then we will just add apply and do something with it, as you can see here with this business logic R function. Unfortunately, it doesn't work. It has some issues, like read lines is reading from the console, not the C-level standard in, so had to change that. The JSON can be malformed, so we have to add some error handling, and a few other issues. So instead of this approach, I tried to solve these and created an R package called AWR Kinesis that you can install from CRAN. You can see in the background it will install a very small package, only 3 kilobytes, but actually at installation time it will download those 60 megs of jar files. Sorry for that, but that's really required so that this thing works. And once you installed, using this tool is very simple. Load the library. We have a Kinesis consumer function. where you can just provide an anonymous function or a function of your package or script, and it will take one argument, which is called records. That's a standard data frame object. So your function has to be able to process all the rows of a data frame, and that's it. So here what I'm doing, I'm just logging every single record to the console. And we could have a stream processing engine in 3 lines, and I think it cannot be easier than that. I really love what RStudio does, but I have to emphasize here, because I got a few questions on GitHub and in emails, you cannot run this in RStudio, because if you run this, RStudio has no idea which stream to read from and how to read from Kinesis. So this R script has to be run by the Java daemon, which communicates with the R script via standard in and standard out. So instead of running this in RStudio or from the console, you have to write a config file for the Java daemon, which simply references the executable, which can be a simple R script. Of course, you provide a stream name and an optional application name, and you start the multi-language daemon with 3 lines of bash command that hopefully we'll see later. So this is a bit more advanced Kinesis consumer, because we not only have the process records function here, but we also have the init, a shutdown, and an updater. In the init phase, what I usually do, I cache some data from a database, because if I'm receiving real-time data, I do not want to spend time on reaching out to a database, load some data, and then respond. I do not want to waste time there. So when the application starts, I load, let's say, user's database, and I can use that in the process records. Of course, that cache data can be outdated sometimes, so I have these updater functions, and you can specify that I want to run a function every minute, every 2 seconds, or whatever, so you can make sure that you update your cache data every few seconds or minutes, so that you can respond based on the real-time data within a few milliseconds. That's really, really performant. So let's run this locally. I think we are at slide 20 out of 60, so I will have to speed up a bit. First, we have to create a Kinesis stream at the Amazon console, create an IAM user. We have to write some data to the stream so that we can read from there, and then we can run the daemon. So I will just step through all these screenshots. This is Kinesis page, creating a stream here. The related access roles. If you're interested, I will post this slide so you can check all the details. This is a short R script to write to this stream. I wanted to stream empty cars, but I was told that nowadays I really have to use the flights data set, so now I'm just picking one row of the New York flights package and pushing that random row to the stream that we will use. In the next few minutes, this is running in the background now. This is how it looks like in ESS. Just a reminder, this is our application, which will just say hello very politely when we start the application, then we will log the number of records received. When the application is shut down, we will politely say goodbye, and we have an updater just to show how it works. So this is the 2-liner or 3-liner to start the Java daemon, and just like all Java application, it throws out tons of logs. Some of these lines are actually useful, but it's better to check the R logs, I think. Here you can see the shard ID, so you know which shard contained that record, and you can see that the application was started, we received a few records, and the updater function run. Okay, so that's how you run this locally, but obviously you want to run this in the cloud, not on your laptop. So first steps, what I would suggest, Dockerize your application, and then you can run it anywhere, basically. To do that, you need to add Java, R, these packages, and your application, of course. Easiest way to do that, push to GitHub, set up a Docker Hub account. Docker Hub will build your Docker image automatically, and then you can run it in EC2 with EC2 container service with a few clicks. So to help you, I created a template for this Docker file, which will provide the Java command and will install the R packages. So if you want to have an application like this, you can create a Docker file like this with 2 lines, which is static, and here you just add your R script, which is your stream processing application, which is like this one in this example. This is the config file for the multi-language daemon, very, very simple things. And then you push it to GitHub, you connect that GitHub repo with Docker Hub. Docker Hub will build the Docker image, and then you can use that in ECS very easily, like it's 4 or 5 screenshots. You can configure where to store the logs and so on, but believe me, that's very, very easy. And here we go. This is now running in the cloud. I just SSH to this Linux server, part of this ECS cluster. Thank you. And you can see that it's running. Similar logs that we have seen on localhost. But what's interesting here, you can see that the shard ID was 0, but sometimes at one point we said bye. The application was stopped, and you can see that the multi-language daemon started 2 our sessions right away. So we had a short split into 2, and the multi-language daemon told the 1 hour session that, okay, stop now, started 2 other one, and from now you can see that shard ID 1 and 2 were processed. To push this in production, of course, you might not want to push all your code on GitHub if you are implementing some business logic. How to solve that? How I solved that a couple of months ago. Amazon also provides some ways to do that, like they have this useR, which is like private Docker repos at Amazon, and the KMS service, which is like an encryption service on demand. So Amazon provides an encryption key for you that you can use, but you don't have physical access to the key, but you can do API queries to encrypt and decrypt stuff. This is how it looks like. So you just send a string to Amazon, they will encrypt, they send back the data, and you can do the other way around as well. We don't have time to get into the details, but you can see that we have very simple interfaces. You want to encrypt a string, just use the KMS_encrypt or the decrypt function. Okay, and just demoing this application, I created a very simple consumer app which will check this stream, count the number of flights to a destination, and increment a counter in a Redis database. That's all what's being done here. I pushed this to useR, and I created a very simple Shiny dashboard which is interacting with this Redis database. So the Shiny application will read the number of flights to the different destinations and will show a very simple tree map, which looks like this one. We don't have time to do this demo, but very happy to show that later in the break or something like that. But just to summarize what's being done here, we have a stream populated by some record producer. We have a stream consumer, which is just counting the number of flights to a destination. We are updating that counter in a Redis database, and this Shiny application is interacting only with the Redis database, and that's updated every 2 seconds. And this is almost real time. So you have, from the time you push the data to the stream, within 2 seconds you see the updated numbers here. So that's on GitHub, on CRAN, and okay, this is my favorite slide. If you would miss, Amazon's web service abbreviation is AWS. So as we all know, it's so 1992. So it's time to use like more modern interfaces for that stuff. Thank you very much.